Hello, good afternoon, everyone. Okay, so today I want to continue going over some of the types of questions that will be on the second midterm, or the second exam. So let's see here. Okay, let me share my screen. Okay. Oops. Okay. So let's just start off with a really quick warm-up. This is going to be like a domain question. Domain of f of x is equal to, let's go 3x plus 2 x squared minus 9, and write it or express it in interval notation. Okay. So try this one for a few minutes, and then when you got the answer, just message me in chat and we can go over it. Yeah. Oh, interval notation is the notation with the brackets, with the square brackets or the parentheses, depending on if you have the endpoint or not, and also the stuff with the union. If you have different intervals, like if there's a hole somewhere, you can have it set up as one interval, union another interval. Oops. And when you think you got the answer, uh, please message me. So yeah, in your answer, make sure you write the full intervals, like 3 to 7 in parentheses or brackets, union 8 to infinity or something like that. And there's something a little bit tricky here. Not really that tricky. I mean, once you see it. Go for it, Mason.
So pretty much what I did for this is I knew that the numerator can never be, if you took the numerator by itself, it can never be a negative inside of the root.
Mm-hmm.
I figured out where it crossed the line at 0 because it's a linear equation.
Good.
That would be at -2/3.
Excellent.
So pretty much I knew from there up is going to be where the domain is going to be. But when I looked at the denominator, I noticed that at 3 there's going to be, I believe, a hole. No, it's not a hole. But 3 is also undefined because it's no solution.
Mm-hmm. Yeah, it will be like we'll get into it later, I think, a little bit, but it'll be kind of a whole, like a asymptote, because you're dividing by 0. But it's just going to be undefined there, definitely. So denominator is it factors x plus 3 times x minus 3, and if you don't want it equal to 0, so what did you observe about the denominator? What numbers are bad?
Both 3 and -3 are bad, but
Excellent.
since it needs to be it needs to be greater than -2/3, you only really care about the 3.
Excellent. Awesome. I'm glad that you saw that. Did you draw it on the number line, or how did you kind of put these pieces together?
I kind of did it mentally, but I did imagine like a little graph in my head.
Excellent. Awesome. Yeah, -2/3. You have a hole here at -3, and you have a hole at 3. But that hole at -3 doesn't really matter because it's, it has to be, you're not allowed to be below -2/3 anyhow. Okay, so putting all this together, what do you write down as your intervals? Mason, you want to finish it off?
Sorry, can you repeat what you just said?
Yeah, so putting it all together, how would you express it in interval notation?
I believe interval notation. Sorry, I kind of was out of it.
No problem.
What I did was parenthesis -2/3,
Now,
comma.
do we want that parenthesis or bracket?
We want a parenthesis.
Well, it could be -2/3 because it's in the numerator. So you are allowed to have 0 there.
So yeah, never mind. It would be bracket then.
So that would be bracket. But the
Yeah.
next one, what about the 3?
The next one though, if you have, it goes up to -3, which is a parenthesis because you cannot have 3 as a
Good.
solution.
Exactly.
And then you would do the union. Once again, a 3 with a parenthesis to infinity.
Awesome. Perfect. Great. So I like this question. Thank you, Mason. Very good. I like this question because like it forces you to kind of write down and think about your conditions that you're required to have, and then group them all together and realize that some of them are sort of redundant, like the x is not equal to -3. Well, you don't need to bring up -3 because it's not going to be part of your intervals anyhow, because x has to be greater than -2/3. Nice. And this is like, this type of math is really just sort of getting comfortable with the language. Like you're not really solving much, you're just getting comfortable talking about these different types of objects and what things you're allowed to plug in and how to express it as an interval. Are there any questions for any part of this warm-up? And by the way, this factorization, I don't think we actually, so one student asked, do you solve the f of x? Yeah, so this question is interesting. You don't need to graph f of x or really understand much about it. So okay, a few good questions here. The denominator. Okay, so one good question, and I know I don't think we brought this up in the class before. So one student asked about how do we get this denominator? How did I turn into this? Does anyone remember what this is called? This is a special factorization. Anyone want to just say what it is?
Perfect square.
It's related to perfect square. It's a difference of squares, difference of perfect squares. So if you ever have this is something that you might have seen. So this is a difference of squares factorization. And it's kind of like foiling, but I mean, it is a very special case of foiling, or factoring rather, when the middle term is 0x and the last term is a perfect square. So difference of squares. If you have a squared minus b squared, you can rewrite this as a plus b times a minus b. And if you FOIL it out, you see why it happens. You get a times a is a squared, plus b times minus b is negative b squared, and then the cross terms will just end up canceling because it's going to be BA and negative AB, so they're going to cancel. So that's how you get the denominator. You recognize that it's x squared minus 3 squared, so it's x plus 3, x minus 3. The numerator, to deal with the numerator, whatever is in a square root, if it's in the numerator, if there's a square root in the numerator, then the only restriction is that the square root, whatever is inside of it, has to be greater than 0, because we're not allowed to put negative numbers, at least for now, we're not allowed to put negative numbers inside of the square root. So that's how I get, that's how I get whatever is in there. I just put just set it equal to be greater than or equal to 0, and then I solve that inequality. And then this is an interesting question. I want you to ask, if x squared minus 9 is changed to x squared plus 9, how would that change things? And it actually turns out that if you have x squared plus 9, then that is, if you look at the graph of that, that's not going to actually have any real roots, because it's just a parabola that was pushed up by 9. So there's no x value that's ever going to make it negative, because you're doing this, you're squaring a number and you're adding a 9. There's no way that's ever going to be 0, unless x is like a non-real number, which we haven't talked about yet. But for most numbers that you can think of, that won't give you 0. So if that's the case, if it was x squared plus 9, you don't have to worry about this factorization. It's just not going to factor. You know, some cases we'll learn later, sometimes you have a quadratic and it just doesn't factor. You just have to leave it as it is. In that case, you would just simply write negative 2/3 to infinity. And you don't need to worry about any 3 or minus 3, because there's nowhere in the denominator that gives you any problems. Okay. So those of you who asked those questions and any other ones, did that help clear it up a little bit, or do you still have any questions? Okay. So let's move forward. So today I want to do a little bit on a really nice type of problem related to absolute value. This is actually a really simple but incredibly useful idea to master, because it's just nice to know for standardized tests and in general for talking about math. So absolute value inequalities. Okay. So the first thing is, what do you guys think about this equation? So what does absolute value do? So if I anyone want to volunteer to explain kind of what absolute value does? Nice. All right, so I have Archer said remove negative. Removes negatives. Or Hannah suggests a good idea, outputs can't be negative. So you plug in any number and it just makes sure that it's not negative. If it's negative, it makes it positive. Okay, so I'm going to write something now. I want you guys to be ready to vote yes if it makes sense, and no if something is off about it, and if it never makes sense. So what do you guys think about this equation? Absolute value of x equals negative x. Can this ever happen? Hit yes if you think it can happen, and hit no if you think it cannot happen, if it doesn't make sense. Okay, so far we got 13 no's. Can this ever happen? This is a really famous trap that several students are falling into. So let me phrase this down here. And maybe I didn't ask it the best way, but what do you guys think about this equation? And anyone have any kind of, a lot of people are saying it can't happen, but is there any merit to this equation? Can we? Let me rewrite this one. Anyone gonna kind of defend like some way to interpret this other equation? Can this ever happen? That when you put an absolute value on an x, you put a minus sign in front of it? This is a really famous like little trap. Because we're told that absolute value always takes away a minus sign. So how could it be that in this case, absolute value adds a minus sign? Yeah, exactly. Absolute value, Allison made a good point. Absolute value makes something positive. So what's going on here? Why am I writing this? Anyone have an idea? And it's really silly. Once you see it, you'll be like, oh yeah, come on, I see what you're doing. And it's a really important thing to be careful with and keep in mind when you're working with absolute value problems. Parallel universe. Yes, maybe it's like the not absolute function that always makes the number negative. Okay, anyone? There's one really simple. Can you mentioned it takes the opposite. Do you want to elaborate on that? I like where you're heading there. Okay, let's try this. Let me plug into the formula absolute value. What if x? So we know that if yes. So you guys give me a lot of good definitions, and all of them I like. One definition to consider is the following. And we're not going to really use this definition too much, but I just want you to kind of be aware of it. Absolute value of x can actually be two different things. Sometimes it's equal to x if x is greater than 0, but other times absolute value of x is actually the negative of x. So absolute value of x is equal to negative x if you plug in x is less than less than 0, if it's a negative number. So in other words, absolute value of -3, this is equal to negative of -3, which is equal to +3. So one kind of really important idea when you're doing absolute value problems is if you see an x, don't make any assumptions about it being positive or negative. X has no inherent sign. So negative x, therefore, isn't a negative number. And positive x isn't a positive number. It's just an x. It could stand for anything. So all negative x means is the opposite sign or the opposite, the additive inverse of whatever x is. So there's no inherent sign to x or negative x. Okay. So are you guys okay with this formula now? Now that you see it, do you see kind of where I was going with that? Okay, so so that's one idea of absolute value, is that it takes a number and whatever you plug into it, it takes the the distance it is from zero. If it's negative, it turns it positive, and if it's positive, it keeps it as positive. And that's the usual way kind of we're going to set these things. Well, that's the usual way you're taught to think about it, and it's introduced. But really, there's a much more important idea that's really all about why we even have and why we even talk about the absolute value function. By the way, if you were to graph y equals absolute value of x, does anyone know what the graph looks like? This is just something I'll mention here. Can anyone tell me? It's a V, right? Because, you know, if you plug in positive numbers, like 1, 2, 3, you get out other positive numbers, 1, 2, 3. And if you plug in the negative numbers, -2, -3, you still get out the same size of number, but it's going to be the positive version. So this is the graph. Okay, please hit yes if you're comfortable with this definition that I'm gonna highlight in green, and please hit no if you're kind of a little bit confused about what I wrote there. Just take a moment to, yeah. Okay, so a few students are a little bit, about half and half are a little bit confused there. All this is saying, this kind of definition is saying, like, it's a function. This is a function. Absolute value is a function of x. You give it a number, and it's called the piecewise function, because what it does is it gives you a different formula, or it gives you a different rule depending on what type of number you give me. You know, a really simple example of a piecewise function is like, let's say you are giving a final exam for different grades, and it's like, okay, well, I got to find out what grade the student is in, and then based on that, whatever category they're in, then I give them that final exam. So so this in this example, the piecewise part is just saying the first part. Well, I guess I like to start from the, you know, usually start from the bottom piece and then go to the top piece. So it goes from left to right. I mean, either way you could write it, doesn't matter. But the bottom piece tells you, okay, when x is to the left of the origin, then the formula you want to use is -x. So this line here, you know, this thing is just this part, this line. This is y equals -x. But we don't go all the way because we're gonna switch up the formula to the other part here, right, like that. So when x is greater than 0, we use a different formula. And if you think about what this is doing, this is just doing that rule that you make a number. If it's positive, it stays positive. That's the purple part. And if it was negative, you actually switch it and you make it positive if it started off negative. And that's the orange part. Okay, so that's the one definition that I'm sure you probably have kind of worked with. Maybe you haven't seen the piecewise definition, but I'm sure you've seen the main idea. But I want to talk about another important definition of absolute value that I think is overlooked sometimes. But it's really why we even talk about absolute value in the first place. So I think you really need to know it because it's the only reason that we even have absolute value. So here's the question. This is absolute value as a tool for describing distances. Okay, let me ask you guys a question. how far apart are San Diego and LA? Or how far, let me ask you this way. How far is San Diego from LA? What do you guys think? Anyone want to give me a guess? And yeah, maybe about 200 miles, depending what parts. I think that's pretty reasonable. Oh, Amy says 100 miles? 115, 125? Okay, let's, anyone plug it into Google Maps? What does Google Maps say? 124.3? Okay. All right, well, we can make it 124.3. 124.3 miles. Okay, now here's a follow-up question. How far is, let's assume this answer, how far is LA from San Diego? What do you guys think about this one? How does it compare to the last answer? Should it be any different? It's going to be the same thing, right? LA, San Diego to LA, LA to San Diego. It might take more time or less time depending on traffic, but the distance, if you're talking about the same road, is going to be the same. That doesn't matter. And that's a key idea. So let me ask you now about the number line. So how far is the number 2 from 5? How far apart is the number 2 from the number 5 on the number line? 3, right? Nice. Okay. Now, let me ask you this question. How far is A from B? Because maybe I want to come up with a formula for the distance from A that A is from B. Nice. You could just subtract. Does everyone agree? You can take the B and you can subtract A. Awesome. So the distance from A to B, or from B to, yeah, from A to B is B minus A. Okay. Anyone know what I'm going to ask next? Let's apply this formula. Anyone want to take a guess? Yes, exactly. I'm going to ask now, let's do the formula. How far, let's use the formula, is 5 from 2? What happens if I do the exact pattern and I do the exact formula? I get the negative, right? I get 2 minus 5, which is equal to -3. So, and Archer made a good point. If I switch instead from A from B, and I say B from A, I'm going to get A minus B if I use the same pattern. So what can we do this? What should we introduce to avoid this situation? Because we just want to talk about the distance from one place to another. We don't care which one you're talking about first. So, nice. I want to take that expression, B minus A, and I put it in absolute value. And that tells me that I don't care if I have B minus A or the opposite of A minus B. Whichever one I subtract from whichever, doesn't matter. I just want to know the overall distance. And that's why we have absolute value. So the correct formula is, so we want to make sure to introduce absolute value so that we say the distance from A to B is equal to absolute value of B minus A, or alternatively, it's also equal to the distance from B to A. So both are the same. And that's the idea, that we get rid of the minus sign and we just talk about the positive distance. And once you have that, this idea that this is what absolute value represents, it actually makes a lot of problems very, very easy to see. Like you don't even need algebra, you can just draw a picture. And I think I really like that idea. And later we'll talk about how to do these problems with algebra, but I want to first give you a lot of intuition with these. So this formula that I'm highlighting in green, this is one formula that I just want you to have seared into your mind. The distance from A to B is the absolute value of the difference B minus A, or if you wanted, you could even do A minus B. It doesn't matter because you're taking the absolute value anyhow. And if you think about this, this also represents, if you make B equal to 0, or rather if you make A equal to 0, then you can see that what the normal absolute value expression does is it just describes the distance from the origin. So if a number is like 7, the distance from the origin is 7. If the number is -7, the distance from the origin is still 7. So that's kind of one nice idea there. Okay, so now let's think about some inequalities. So, the way I want you to write these is to first convert the math expression into an English sentence, maybe first by writing it down completely, and then later, once you do it, you can just say it in your head. So try out this one. Absolute value x minus 5 is less than 2. So express the solution set to this absolute value inequality in interval notation. Or first do it on a number line and then do it in interval notation. Now, before you jump to the answer, can anyone translate this, and let's do this one together. Can anyone translate this into an English sentence? So a full English sentence. Translate the entire inequality into an English sentence. Okay, now that's good. Now can you, Gabriel wrote the absolute value of x minus 5 is less than 2. I like that. But now don't use the phrase absolute value. Convert it to the distance. Because absolute value is, it's a little bit tricky to think about it. Nice. Lily, do you want to share what you wrote?
I just said the distance between x and 5 is less than 2.
Perfect. So the distance between x and 5, and that's the same as the distance from x5 to x or x to 5, either way. I like this. The distance between x and 5 is less than 2. Whoops. Okay, so what does that tell us about the number line? Where can x, think about this, where can x hang out? What number does x have to be close to? We don't know where X is. But if I tell you, imagine I told you guys, say, the distance between you and Claremont High School has to be less than 3 miles. How would you describe like where you're allowed to hang out? If I say, you know, you're not, oh, you just at your house. Well, you can hang out anywhere you want as long as it's less than 3 miles away from, you're not allowed to go more than 3 miles away from Claremont High School. So that would, can anyone describe what kind of shape that would give you? Yeah, that would, Kristen, nice. That would be like a radius of 3 miles. So you can't go outside of that region. Now, we're not, when we're talking about the number line, it's kind of similar, but it's even simpler because we don't have a circle that like with a radius of 3 miles, but we're just gonna have an interval. So can anyone interpret, if I say the distance between X and 5 is less than 2, where is X supposed to like hang out? What's the number that it's supposed to be close to, and how far away can it go? And so like what would represent like the main area that X would have to be close to? Nice. Hannah, do you want to explain how you got that?
I drew a number line and then I put 5 in the middle of it. And then I went 2 spaces to the left and to the right. And then I knew it had to be between 3 and 7.
Excellent. So 5 is like, if I say you can't go more than like 3 miles away from your high school, then 5 is like where you're, like the center of where you're supposed to be. And then you just go 2 miles, like the furthest away you can go to the right, and the furthest away you can go to the left. That's it. So, and this is, believe it or not, an interval is actually, you can think of it as a one-dimensional circle because it has a center and it has a radius that goes either way. And the center is just the midpoint. So the answer here is 3, 7. X can be anywhere, X can hang out anywhere in that region. This region is totally okay because it's within 2 units from the number 5. Please hit yes if this kind of way of thinking about it makes sense. And hit no if you're a little bit shaky on how I got this picture. Okay, cool. Let's try some examples where you can do it on your own. And once you see it, don't just try to memorize like, okay, this goes there. This really say the English sentence and actually think about what it means. Like when I asked you guys, when I made the statement like, oh, you can't be, let's say, more than 3 miles away from your house. If your parents told you, hey, you're not allowed to go more than 3 miles away from your house, you would know what that means. Like that means you can't go like more than 3 miles away. You have to stay close to your house. So it's the same thing. Just convert the math equation to an English sentence and then think about where X is allowed to hang out. So let's do another one. How about this one? X minus 7 is less than 10. So think about it a little bit. Make sure you write the English sentence. So please message me the sentence. And then also, once you do that, draw it out and then message me the interval that you got. All right, nice. Getting a lot of good sentences. All right, I'm glad you guys are writing down the sentences. They're very good. And I'm seeing everyone's getting them correct. And now, once you get that, draw a number line and all right, Kanjit, do you want to share how you thought about it?
I basically did the same thing where I put 7 in the middle, then went 10 over and then 10 back, and then I got -3, 17.
Awesome, thank you. So you got 7 here, and you go, this is the distance between x and 7. That's how I'll write it out. And later, when you're more comfortable with these, you don't need to write out these sentences, but you do always want to be saying them in your head. So the distance between x and 7 is less than 10. So that tells me, okay, 7 is the middle of my interval, and I got to go 10 over to the right. That gets me to 17, and 10 over to the left. That gets me to -3. So the answer is -3, 17. If you were to highlight, you can be anywhere you want, but you can't be exactly at the boundary because it's strictly less than. So you got to be within the boundary, and you can be anywhere in between that range. Okay, now what if I change this answer to make it, how would it be different if it was x minus 7 absolute value is less than or equal to 10? What would the only difference be here? If I change to be a strict inequality to, nice. Hannah says it can be equal to -3 and 17 in addition to kind of being in between them. So we would just change it to brackets. So that's kind of an easy thing to remember, is that if it's a strict inequality, you're going to use parentheses because you don't want to include the boundary points. But if it's a less than or equal to or greater than or equal to, you are allowed to actually plug in the boundary points. So this would be, in this case, it would be the same numbers, but with the brackets instead. Okay, let's do another example. Now, instead of saying less than, I'm going to say greater than. And I'll give you another one. Let's say now I do, so find the solution set to this inequality and write it in interval notation. The distance is greater than or equal to 5. So think about this one. And before, I would say the idea is like if somebody tells you, hey, the distance you can be from your house is less than like 7 or less than 10. What did we have previously? Yeah, the distance you can be from your house, which is located at position 7, is less than 10 miles. Then you have like a region where you have to hang out close to your house. So how does it change if you say x minus 2 absolute value has to be greater than or equal to 5? What does this one say? Nice, Gabriel. And message me when you got the intervals, or if you're kind of not sure. I recommend writing the sentence, drawing the number line, and then giving the points. Nice, Hannah. I like the creative way of writing infinity. That's good. Ivan, does your answer take into account the greater than sign? Think about that carefully. Gabriella, do you want to volunteer and say what the sentence you got was?
Sure. The sentence I put was the distance between x and 2 is greater than or equal to 5.
Awesome. Distance between x and 2 is greater than 5. So does that mean that we want to be really close to the number 2 or kind of further away from it? If I was to graph it, here's 2. Where do I want to hang out? Nice, I want to be further away from it, right? So if I plot 5 units away, oh no, that's going to be, sorry, that's going to be, this is 5. If I go 5 to the right and 5 to the left, this is 7 and this is -3. And I'm saying that I want to be, the distance between x and 2 should be more than 5 apart. So x can't be close to 2. I think of it as like, your parents are worried about you, so they say, don't go more than 3 miles away from the house. This is kind of like the opposite situation. Maybe there's a zombie outbreak and you don't want to be close to the house. So, hey, there's a zombie outbreak at the house, which is located at, block 2. You don't want to be within 5 blocks of that house. You want to be more than 5 blocks away. So you can hang out outside of the zombie outbreak. And actually, Archer wrote, maybe your parents have a restraining order on you. And by the way, hang on, guys. Sorry, I just have a call here from the hospital. One sec. All right. Yeah, sorry about that. Just a survey. Okay. So yeah, so maybe your parents have a restraining order. And another thing that this is actually really relevant to nowadays is, you know, the whole social distancing. You have to be at least 6 feet away from other people if you're in the supermarket or something. So that tells you like the distance you are from somebody else or from somebody at this position has to be at least 6 feet away. So you can hang out anywhere, but you're not allowed to hang out in a 6 foot radius of that person. So I never thought that we would have a really actual down-to-earth example of this type of inequality, but it is very useful for talking about things in math. Okay, so yeah, we would describe this as negative infinity to -3, and because it's greater than or equal to, you put a bracket union 7, comma infinity. Okay. So hopefully what you're seeing here is that we're doing these problems and we're just thinking about what they actually are talking about. We're not solving any sort of algebra or anything like that. We're just going from what they're saying and we're thinking about the English version and interpreting it and drawing a picture and then writing down another way of expressing it. So I really like this type of math where you see that a lot of math is not necessarily about solving stuff. Solving stuff is very important, but a lot of it is about interpreting things and understanding kind of that sometimes equations are just expressing like different shapes and conditions, and we don't need to overcomplicate things by doing a bunch of algebra that hides the main picture. Okay, let's do one more question. Please give me a yes or a thumbs up if you are comfortable with this example and you are feel like you're ready to move on. Cool. And again, try not to memorize, like don't focus on memorizing rules. Think about what the thing actually means and then interpret it, draw a picture, and then write your intervals. I wouldn't come up with a rule like every time it says greater, yes, it's going to be, you know, the absolute value is greater. Yes, it's going to be 2 separate intervals. Like you can come up with rules like that, but I really, really discourage those types of, that type of thinking. Okay, so I want to ask you guys a slightly sneaky one and see if anyone can connect it with all the problems that we did before. So how about this one? Absolute value of x plus 7 is less than 4. So first, how is this one a little bit different than all the other ones that we saw before? Nice, nice. Both Gabbies say the plus sign. And hey, nice, you got the plus sign. Okay, good. So it's a little bit confusing because we said that the distance between x and 7 is x absolute value of x minus 7. So we can't do that here. Anyone have an idea of how we can maybe rewrite this in a sneaky way to introduce a minus sign so that we can apply this, this way of solving it, or this way of thinking about it? How else can we think about x plus 7? Archer, close. Not, you're on the right track. Not exactly. So a few students wrote negative of everything. Not exactly. So we did, oh, one thing with these questions, by the way, is, and I should mention this, if I told you like the thing that you're comparing against, if I say the distance is less than -3, well, that's impossible, right? Like if instead here I wrote a negative number, it just wouldn't make any sense because distances always have to be positive. So there's never a way you can have a distance be less than a negative. And later in the course, we will do more complicated inequalities where we will have to do it algebraically. But just these basic ones, I do want you to know this method of doing it. Any ideas how we can turn this into a problem that we can approach exactly the same way that we did earlier? And it's a really sneaky thing. In math, there's something that's true that in real life they say is not true. I don't know if that. What do they say about two? Okay, time travel. Yeah, that's really weird statement. Really vague statement I just made. But what have you guys heard in real life? Do two wrongs make a right? No, right? But what about in math? Do two wrongs make a right in math? Yes, two negatives make a positive. So that plus sign, what's another way we could, RJ, yeah. Okay, but bad things happen to a bad person and that's good. You know, we never want anything bad to happen, even if the person is not that good. Excellent. So in math, we do have this idea that if you see a plus sign, you can replace it with two negatives. So you can write it as x minus -7. And I'm not changing overall any negative sign on the whole thing, just I'm replacing a plus sign with minus minus. And this is kind of a handy trick that shows up in lots of like places in math. This is not the only time that we'll ever see this. And believe it or not, it shows up in all types of math. So just like if you ever have a formula that needs to have a minus and you have a plus, just think of it as minus minus. So now this is saying the distance, because we have a minus in between two numbers, so we can talk about subtracting them and taking the absolute value, that's the distance. The distance between x and -7 is less than 4. So if we draw that picture, now our center point is -7. We go 4 over to the right. That's going to be -11. And 4 over to the, oh, that's 4 to the left, sorry. 4 to the right would be -3. So that tells us that x is in -11, comma, -3. And I don't want to include the endpoints. Okay. So that's how you can handle these problems if you see a plus sign instead of a negative sign. One kind of really important thing, I don't even want to write it down, so I'm just going to say it. I'm going to write it, but then I'm going to erase it. If you ever see an equation like this, absolute value of x minus 3, this does not necessarily equal, like a lot of people make this mistake when they're just kind of rushing through absolute value. It has nothing to do with just flipping an individual sign. You can't just say, oh, this turns the -3 into a +3. This is not how absolute values work. They don't just change the minus sign to a plus sign. They affect the entire expression. So what you could write is, this is equal to two possibilities. This could be either, x minus 3 or -x plus 3, depending on what if x minus 3 is positive or x minus 3 is negative. Okay, so that's just kind of one thing to keep in the back of your mind. This is more relevant when we're doing the algebraic way of solving it. Okay, what do you guys think about all of these ways of drawing these pictures and rewriting an absolute value inequality as an interval or a union of two rays or two intervals? Do you feel comfortable with all the different examples? Sweet. Take a look this weekend over the practice test, and you'll see some more examples that you can work on. And just redo these examples, and I think you'll have a good sense of it. Okay, there's one more thing that I want to do, and then I'll let you guys go. The last question is going backwards, and it's really straightforward. So let's go in reverse. So if I give you an interval, can you find the absolute value inequality that it represents? And the last thing after we do this is I'll share with you a little bit of why this kind of notation and thinking about distances and intervals is really, really useful. Okay, so let's go backwards. So this time I'm going to give you the interval, and you need to give me the absolute value inequality. So the interval now is going to be from 4 to 20. So what would the absolute value inequality be? And the hint is, think of that interval as a one-dimensional circle. Find where's the home, where's the center of that circle, or the center of that interval, and what is the radius. Perfect. Gabriel, do you want to share how you got those numbers?
Sure. So I kind of like figured out what, it was like kind of mental math, but I kind of figured out how, like where the like middle point of 4 and 20 was, which was 12.
Nice.
And then just to check, I made sure like 12 minus, and like, I made sure like 12 plus 8 equals 20 and 12 minus 8 equals 4, just to make sure so it's right. And then I got x minus 12 when the absolute value signs is less than 8.
Perfect. And you did it with just kind of intuition, mental math. What's a nice way to find the middle point of two numbers? What's a nice formula for that?
Add them together and divide it by 2.
Yeah, exactly. Find their average. That's the way to do the midpoint. Just take two numbers, add them together, divide by 2. So that way you can find the midpoint. And then once you have the midpoint, it's really good to check, okay, is it the same distance away from the endpoints? That's it. If it was like one of the intervals that we did earlier, like let's say negative infinity. So try this one, negative infinity to negative 10, union 2 comma infinity. So this is a good one to try out. What would this absolute value inequality be? Oh, I'm sorry, I forgot here. You want, because it's brackets, you want to make sure that it's strictly less than. Oh, sorry, less than or equal to, not strictly less. Anyone have any thoughts on this one? If you draw it out, so this time, and I'll kind of start off by a little bit of drawing it. This time we're talking, it's going to be absolute values greater than something. Nice. So we have -10, we have +2 over here, and we want the outside of the interval. So we want to be away, some distance away from the midpoint of this. What's the midpoint of -10 and 2? That's going to be, add them together, divide by 2, you get -4. And you can just double check that -4 is 6 away from this, from the right side, and also 6 away from the left side. So the final answer is going to be absolute value of x minus -4. The distance from -4 has to be greater than or equal to 6. And that would make sure that we stay away from that number -4, at least 6 feet away from -4, or social distancing. Okay.
Could you also write it as a plus?
Oh yeah, exactly. So then to make it look neater, you would write x plus 4, absolute value x plus 4 is greater than or equal to 6. Very good. I'm just gonna, are there any questions on any of these examples? Oh, it's just +4 because I just changed the minus to a plus. That's all. Is that okay? Any questions on any of these? By the way, when you're doing these, what do you notice about the x in all of the questions? It's just a simple, exactly, it's just a simple 1x. We don't have anything like 3x or something like that. If you ever encounter a 3x or like 5x or -5x, you can always factor out that number and then factor out from the absolute value part. And then when you factor out something from the absolute value, what's nice to keep in mind is that you can, like if you take out a minus sign or just a number, when you factor it out, you just factor out the absolute value part. And then you can always convert it to a problem like this. But what would happen then is you'd kind of get involved with some fractions. So luckily I never made the midpoint a fraction and I never made the radius a fraction. But if you ever have something where there's a number in front of the x, it might get you into some fractions. Later I'll show you another way of doing these, and I think you guys have probably seen an alternative way of doing these. But for now, I really just want you to know this way, because I think this is just a really nice idea that I wouldn't even say you're solving any math. You're just literally going from one way of talking about something to another. We're just translating different ways of talking about the same thing. Like we're doing English, absolute value inequality, picture, and interval notation. So 4 different ways of talking about the same thing. That's all we're doing. Okay, so why is this kind of useful? And why are mathematicians, why did we come up with this notation? What's the point of talking about intervals? Why don't I can already have intervals. Why do I need to do absolute value inequalities? So the idea is like, if in calculus, you're gonna learn about, one thing you learn about in calculus that's really cool is you talk about parabolas. And one thing you're going to study is you want to understand the slope of a parabola. And it's kind of tricky to interpret what that means. And for a long time, people didn't really know how to approach it. Because a parabola is not a straight line. It's a curvy thing, right? So how do we talk about its slope? But it clearly has some slope, like you can draw a tangent line to it and measure the slope of that. But how do you find the tangent line and how do you figure out the slope? So the idea is, well, I can't do this exactly, but what I can do, and this is kind of the approach where you do something called a limit, is I can take 2 points that are really close to each other, and I can take the slope of those 2 points, the slope of the line connecting those 2 points. Now, of course, that's not going to be just tangent, because a tangent line just grazes it. It only touches, like if you have a parabola, the tangent line is like a piece of string that just touches your curve at exactly 1 point. So this wouldn't be exactly like a tangent line, but it's very similar. So the moral of the story is that in calculus, you want to get closer and closer to a point. So you want to talk about an interval close to a point. So let's say this is the point x equals 5. Now, if I want to be really, really close to the number 5, if I want to be within a tenth of a unit from the number 5, what would that be in interval notation? So if I want to be at most 1/10 away from the number 5, what 2 numbers could I be between? So goal is to be close to 5. What 2 numbers are really close to 5 within 0.1? So I want to be somewhere super, super close to 5. Yeah, I can be 4.9, or what's another number I can be in between? 5.1. So x can be between 4.9, 5.1. What if I want to be within 0.01? If I want to be within 100th? It would be, x can be in, by the way, this symbol means belongs to. Probably should have mentioned it. It could be between 4.99 and 5.01. So x could be in 4.99 and 5.01. And in general, if I pick a really, really small number, I'm going to be between 5 minus that number and 5 plus that number. So an alternative way of writing all of these intervals, for example, the 0.01, is just to write it as an absolute value inequality. And it allows you to kind of take away all the essence of what you're describing. So many times in calculus, when you're trying to describe getting close to a number, being within a certain distance, you might write something like this. Instead of writing the above thing, you just write x minus 5 is less than 0.01. This is saying to be within 100th of the number 5. So it's just a little bit simpler than writing 4.99 to 5.01, because it gives you the essential information. It tells you where you got to be close to and how far off you can be. So that's really kind of the motivation. And then not only that, but later you'll see that we say, okay, well, what if we make it closer and closer? So we don't even use 0.01. We use a number called epsilon, which we think as like a number that represents, it's a variable, but it's just like getting smaller and smaller, getting like not just 100th, but then 1,000th, 1,000,000th, a billionth. So we could write eventually something like this, that we want x minus 5 to be less than an expression called epsilon. So this is this is called a small number epsilon. That tells you that you want to be within a certain distance of the number 5. Okay, so hopefully you guys see a little bit of this motivation of why we have these absolute values inequalities. They're not just to make, for a long time I never understood, like when I was in earlier in high school, I never understood why we're learning this absolute value. It just seemed like we're doing exercises for the sake of doing them. But there is an important meaning that they represent, like a very convenient way of talking about being close to some specific number and what threshold you can be close with. And that's it. Okay, guys, have a great weekend. If there's any questions, I'm happy to address them. So if you guys have any questions, please let me know. But otherwise, I will see you on Tuesday. And before you go, please take a look at, I think I'll post an assignment. Try to read the notes so that on Monday and Tuesday, you feel comfortable solving 3 equations and 3 unknowns. That's like 8.5, 8.4. Oh, I'll see you guys on Monday. I'm sorry, I always forget. I'll see you on Monday. And we'll go over 3 equations, 3 unknowns, but try to just do a little practice on your own. Read through the examples. Is just elimination done twice. So, and this way you'll have a little bit of a head start and you're not just going to be learning it for the first time on Monday. So I really encourage you to do that. Okay, one student asked are there any videos to help clarify the lessons? Let me see. I can look for some that might help on Khan Academy, and then also maybe I'll post the ones that the actual video lessons as well. But yeah, if there's some concept that you're not sure, feel free to ask me. Also, try to. Do you have anyone do you have any buddies in the class that you can work with? Any study buddies? Yeah, so I encourage maybe to get together and see if you can work through some problems together, work through the practice test. That's a good thing to do. But yeah, email me, and then if you still have some questions, I'd be happy to meet like Monday or Tuesday for office hours. Just let me know ahead of time. But yeah, you can also look up Khan Academy. What did we do? You can look up Khan Academy systems of equations and also absolute value inequality. They actually do talk about this way of doing absolute value inequalities as well. And the other thing is just later it's good to slowly read on your own time, try to read through the notes as well. I think that could be helpful. All right, guys, I'll see you next time.